Hello everyone. In this video we are going to talk about basic arithmetic. In order to use the functions that we typically use in arithmetic, we have to import the module called math, and then we have to use lots of different functions. So here we imported math, and then here are some basic things, right? So I have A, I have B, then I define C to be A times B plus 3, and no problem. I can show the results here. And then I can use this plus equal or minus equal, times equal, divided equal operations that we had in C++. We also have them in Python. So we can go ahead and use all of them here. So I can show all of those results for you, right? So I is 1, and then I add 1 to it, and then I can show that I for you here. And you might say, well, would you also have this operation plus plus? So do I have this guy here? And the answer is no, we do not. So Python does not have I plus plus and I minus minus. These operations, whether it's pre or post increment, these guys do not exist. These ones do, but these plus plus operators do not exist here. So let me go ahead and run this initial part, which is of course very easy and obvious for you, right? So you can see the results here. Now let's look at some more advanced functions. So the power, if you remember from my previous lectures in Python, is star star, okay, or asterisk asterisk. That is power, it's not caret really, okay, and it's not the power function. If you want to divide A by B and then get the quotient to be floored, so you want to convert it to integer, use a double /b. If you want the modulus, use the percent sign. If you want the factorial, you have to use math.factorial. Okay, so keep that in mind. You have to use math.factorial. Okay, you cannot use any other thing. It's the factorial function. If you want the permutation of A and B, you use the function perm. The exponential is math.exp. The let's say here the sine hyperbolic, right? If you want the sine hyperbolic, there is sine hyperbolic. There is of course similarly cosine hyperbolic, tangent hyperbolic, and so on and so forth, right? So these hyperbolics, which as you know they are exponential functions, they also do exist in Python. In Python, if you say log, just like MATLAB, just like C, it is natural log. If you want log 10, actually, there is a function log 10 in Python that you can use. And if you want square root, of course, you can use math.square root. So here, I'm going to run it again, although I have the results here. And you see here, 5 to the power 2, then 5 divided by 2 is 2.5. But when you floor it, the result is going to be 2. Right? A modulus B, 5 modulus with 2 division is 1. 5 factorial is 120. Permutation of 5 over 5 and 2 is 5 factorial over 2 factorial times 3 factorial, which is 20. Exponential of 5 is this number. Sine hyperbolic, right, of B, which is 2, is that number. Natural log of 5, like 10 of 2 times 5, which is like 10 of 10, is 1, of course. Square root 2, and you have all of these functions here. I decided for the completeness of this lecture, add a few more functions. One of them is the absolute value function, which is math.fabs. Okay, so just wanted to tell you it's not math.abs.fabs. The other one that you probably, if you use MATLAB, might be familiar with is a sine function, which returns basically a -1 if the number is negative, and if the number is positive, +1. So it's basically the number over its absolute value, right? And for 0, it's not really defined necessarily, right? Unless you give it the value of 0. And the sine function does not exist in the math module. If you want to use the sine function, you have to use the numpy. So here I have added numpy, I have imported it and renamed it to np, And then we have lectures on NumPy, but just wanted to let you know, if you want to use the sine function, you have to use NumPy, and then you have to use npy.sine function, and that gives you what you want. The next two functions that are useful for integer numbers are LCM, which is least common multiplier, and GCD, which is greatest common denominator. And they also exist in the math module, and here we can apply them to the numbers 5 and 12, where one of them should be like 60 and the other one should be 1. So let me go ahead and run that for you. So, and you can see the results here, right? That's the LCM, and this is what the GCD. Other functions are for converting decimals to integers, right? So here I have 5 and 3, and if you divide, you know, the result is 1.66. And here I can floor it, which is the smallest integer its number is between the two. If the number is between two integers, the smaller one is the floor, the larger one is the ceiling. You can truncate it, which is taking away the decimals. And the round function is not in the math module. It's directly a function that is available in your Python. So for round, you do not need math. You can directly use the round function here. And you can see the results here. So when you floor 1.67 or 66, the result is 1, ceiling is 2, round of it is 2 because it's more than 1.5, and truncate is just throwing away the decimal, which is 1. Okay, so these are the four functions that you have, all of them, by the way, in MATLAB as well. About constants, there are several important constants that you can use in math module. One of them is pi, the other one is Euler number, the other one is to define infinity, and the other one is nan, which is not a number. So here I can define pi, and then I can define 2, right? And I can show you all of them, or I can just show you a, for example, right? So let's just go ahead and show you pi, right? And of course, it is going to show it with so many decimals, right? And you learned in the previous video, if you want to show it with so many decimals, you can use that basically percentage sign, and then dots, and then the number of decimals you want, an F, okay? So that's your math, and you can do infinity, right? So if you say inf, then it is going to show you infinity, which of course not a number, but it is just going to show it to you. So if you are here now, of course, and at the bottom I'm going to have a problem with this function, but that's okay. I just wanted to show you a, which let me find it for you here. A is inf, okay? And you can have nan. So let me put it back to pi, and then now we of course have the trigonometry function or harmonic functions. We have sine function, we have cosine function, we have tangent function, and all sorts of functions, a sine, a cosine, arctangent, and so on and so forth, right? So we have all of them. So here what I'm doing is I'm dividing pi by 2, which is 90 degrees, and then a sine of 90 degrees, it is going to be what? This, of course, should be 1, right? So if I run this guy and get the sine function, and you can see that sine of 90 degrees is 1, but the important thing is the input to the harmonic functions is in radians. So this guy should be pi over 2. If you type in 90 degrees here, you are not going to get 1 because that's 90 radians, not 90 degrees, right? So let me take a look here with you. If you say sine of 90, then you see the number is 0.89, okay? So make sure that your input is definitely in radians. Now, if you have a degrees, you can convert it to radians, right? So there are two functions that can convert your degrees to radians and vice versa, and these are math degrees and math radians. So if I want to use 90 degrees here, then I have to say math.radians and convert that 90 degrees into radians like this, and then pass it to the sine function. Then I'm going to be okay, right? So look here. You see? So you can do that. And then, for example, if you want the output of arctangent function, if you say what is arctangent of 1, Of course, the answer it gives you is going to be what? It is going to be in radians, but if I use the math degrees function, I'm going to convert that radians into degrees, so the answer is going to be what? 45 degrees. Otherwise, the number is going to be pi, which is 3.14 divided by 4. So it's 0.7 something. The other thing I wanted to show you is a function that is very important in many applications, including robotics, is arctangent 2. We call it the quadrant corrected arctangent, and MATLAB has it and Python has it, and that's very good. So the input to this function is not a ratio like this. This is not the ratio of sine over cosine of the function. So the arctangent 2, when you pass it two numbers. You pass it basically the sine and the cosine of the number, okay? Or the y and the x of the endpoint in the unit circle. So, for example, if I say the ratio is -1, the answer that you will get is -45 degrees. -45 is the angle for which tangent is -1, but that's not the only angle. There is another angle that has tangent of -1, and that is 135. But arctangent of -1 is always going to be -45 in Python. So we cannot figure out whether the sine was positive, the cosine was negative, or the sine was negative, the cosine was positive. So we cannot tell which one of these two was the real angle, because the ratio of both of these is -1. So what I will do, I would use the arctangent function, and I pass to it sine and cosine, and then convert it, of course, into degrees. And you see for one of them, it says, hey, -45 has what? Has sine negative, cosine positive. 135 has sine positive and what? Cosine negative, right? So you see this one gives you the correct answer. So I recommend you use arctangent 2. That is way more accurate than arctangent. And these are the majority of the functions that we have in Python for arithmetic. So hopefully this video was useful to you. I will see you in my next lecture. Thank you.